let's understand what is the lower bound in binary search. Okay, let me explain what will be the lower bound. Okay, let's say we have an array 1 2 2 3 4 and target is equal to let's say 3. Then we need to search some element which is equal to or greater than 3. Sorry. Okay, so here 3 is equal to this, so the lower bound index will be lower bound idx is equal to 3. What if we are searching for, yeah, we are searching for 2? Then what? 2 is present and it's equal to this 2, so lp idx will be 1. Got it? Now let's take another example, that is 3 5 8 15 19. 3 5 8 15 19. Yeah, let's say x is equal to 9. We need to search case 2. Okay, we need to search 9, 9 or greater than 9. So if you see, this is sorted array, and to a third index means 9 needs to be present here, right? So if 9 is not present, then next greater element, which is 15, will be answer. So LP index will be third. Okay, and next lower bound of 9 will be, means if you search lower bound of 9 in this array, then that will be 15. Okay, so we need to search that out. Okay, now what we need to do, we have two options, right? One is we can search linearly one by one as array is already sorted, and check if that particular element is less than equal to required element or not, right? Means if equal to or greater than, then that particular element will be l- lower bound, right? What else, what we can do, what else we can do? Let me just rewrite it here. Let's say 3 5 15 19 21 is the array, and you need to search for 9. Okay, so this is the case. Okay, now you need to search for 9 or greater than 9. Okay, what you can do, you can have means you can divide it into two part. Let's say middle element will be 15. This is left, this is right, and this is mid. Okay, we'll be using binary search. If that particular middle element is, two cases possible, right? Means it can be equal, three cases, let's say, and then we'll combining 3 into 2. Okay, so what if this middle element is equal? If nums of m is equal to x, what we are going to do, we need to check if there any element this side will be equal to that element or not, right? If not, so this will be the answer. So what we need to do, we need to move our right pointer to these point. Why not to 5? If we move right to 5, means at index 1, then we'll be missing out that 15, means we will be uh, getting a number which is lesser than 9, which is not our requirement. So that's why we'll be moving our right pointer to mid, right? Else if what we can do, nums of m is, let's say, greater than x. If mid element is greater than x, then if that particular is greater, then there is a chance that this side solution will exist, right? Not on this side. So what we can do here also, this could lead to this particular 15 can be part of our answer, right? So we'll be moving right to mid only. We'll not moving right to this point, this particular point, because it will create a problem. Like we'll be missing out 15, and we'll be searching, we'll be anyways ending up at 5. That is something which we don't want. So The last case is you need to move if means what will be the last condition? Just n of nums of m's is less than x. If that particular number is less than x, then you can surely discard that number and move to next, right? So you can move to mid plus 1, means if that 15, let me take it as a pointer. If this 15 is smaller, let's say, for example, let's say right now mid is 5 and you are searching for 9, then you can surely discard 5 because in your answer will be greater than 5, not 5. So considering this index will not work, right? So what we are going to do, we are going to cut L from here and move L to this point. As of now, for this case, aim is at 15, so the right pointer will be shifted here, not the left pointer to this point, right? That is the case. Means this is the thing which we need to implement. Now you can see these two conditions are same, right? So what you can do, you can resolve it into one chunk. Sorry, I need to use pencil. If n of m is greater than equal to x, then we just have to do one thing, that is right is equal to mid, else left is equal to mid plus 1, right? Yeah, this is something which we need to do. Now, till what point we need to run this algorithm, right? Means we need to run this algorithm until, let's say, just a second, we moved right here, and if we see the mid will be this, then we'll be moving this to here, means we need to stop here. Means if left is less than right, till that point we need to run, and right, else we need to stop because that will be our answer, right? What else? What if there is a case like there is no element which is greater than that particular element, right? Greater than equal to that particular element. Let's see that example as well, and then solve, we'll try to solve that as well. Let's say we have 2, 5, 7, 9, and you are searching for 10. Okay, so 0, 1, 2, 3. Now if you see, left is equal to 0, right is equal to 3, and mid will be 0 plus 3 by 2 is equal to 3 by 2 is 1, right? So n of mid is equal to 5, and 5 is less than 10. If less than, means this one, this case, right? Else case. So left is equal to now 1 and right is equal to 3 only. That is first iteration, right? What will be the next iteration? Left is equal to, sorry, left we already know. So mid is equal to 1 plus 3 by 2 is equal to 2. So n of 2 is equal to 7, which is less than 10 again. So you'll be moving to, will be moving left to mid plus 1, that is 3, and right is equal to 3 as well. So in next iteration, suppose that mid will be 3 plus 3 by 2 is equal to 3. n of nums of mid is equal to, what was the value? What was the value? That is 9. 9 is still less than 10. So we'll be moving left is equal to m plus 1, that is 4, right? Now, if we stop when left is less than right, so we'll be ending up at third index both, right? But that will not give us any answer. So we need to take our left to that particular situation. Yeah, to that particular situation. Let's say to a situation where answer exists. So we need to, now it's clear that if the algorithm will be like this, while left is less than equal to right, and if you need to calculate mid here. Okay, if value at mid is greater than equal to x, right? Then right is equal to mid, else left is equal to mid plus 1, and mid will be left plus right by 2. You need to take care of overflow as well. So this will be the algorithm which will be working fine. Now I'll show you with another example, like what if 0, 2, and 9, and you are searching for 9. Okay, means lower bound for 9. So that will be this index, right? So left, right, first time 0 plus 2, 0, 1, 2 by 2 is equal to 1. Value at is equal to 2 is less than 9, so you need to move your left to mid plus 1 is equal to 2. Now it will go for one more iteration. 2 plus 2 mid is equal to 2 plus 2 by 2, mid is equal to 2, value at 2 is equal to 9, and that is greater than equal to 9. So what we need to do here, you can see if that is the case, then right will be moved to m only, right? Right will be, r is already at 2. This will cause a problem. It will run into infinite loop. Now what to do? So we realized one thing, like what if we consider our array in such a manner, like 0, 1, 2, 3, and let's say 0, 2, 8, 10 is the array, and let's say your left is here and your right is here, means pointing to nothing. Okay, now this will work, I guess. If right will be not in inclusive range, then will that formula work? Let's solve that out. Okay, so now let's say x is already 10. Okay, now you can run uh, 0 plus 4 by 2 is equal to 2. That is this. Value at 2 is equal to 8, and that is less than 10. It means we need to move our left to mid plus 1, that is 3, right? Now 3 plus 4 by 2 is equal to 3, right? This will be mid. Value of mid is equal to 10, which is greater than equal to 10. So right is equal to 3, and we know that L is equal to also 3. Now this are same, means we can stop our algorithm there. What change is required now then? If you see in this algorithm, we just used one case. Can I use eraser? If we just erase this condition, this algorithm will work fine, right? Yeah, this will be the case for lower bound. And one more thing we can do, we can try run this out and test it. But yeah, let's go, because I know that will means my intuition says that this particular algorithm will work. And just to be sure, I'll be running it one more time with an example, where means we already ran an example where 10 exists. What if we are searching for an element that does not exist? Okay, let's get back here where the formula was and create one array, like let's say 0 and 3 and 9, just 3 element, and we are searching for something which is not present, let's say 10. Okay, 0, 1, 2, and that is third index. Now left is here, right is here, so what will be the mid? Mid is equal to 3 plus 0 by 2, that is 1. Value at 1 is equal to 3, which is less than 10. It means we need to move left to m plus 1, that is 2. Now if you see one more time, then left is equal to 2, right is equal to 3, and mid will be 2 plus 3 by 2 is equal to 2, right? And that particular value is still less, means is value at 2 is equal to 9 is less than 10. It means left will be moved to one place more of mid. Mid plus 1 is equal to 3. So here is the case where we can stop because left is no more less than right. You can see left is no more than right. So this particular algorithm will give us our answer. This is the lower bound LOWR, lower bound algo. Okay, yeah, and that's it. I was taking time to explain, and that is not really required, I guess. But yeah, let me run that algorithm. I don't have premium subscription, so I'll be able to solve just few cases only. Let's see if that work. Okay, so in Python, left is equal to 0th index and right is equal to len of nums. What we need to do, while left is less than right. Okay, what next? Mid. Mid element is equal to left plus right. We need to place it like this, divided by 2 if nums of mid is greater than equal to x, right? What we need to do is right is equal to mid, else left is equal to mid plus 1, right? Means, yeah, place where left will end will give us our answer. So return left. Yeah, that is the code for lower bound. What else we can do is we can have some other tab and check it in new window. Let's say I want to search Gemini Google Gem as my code, right? Test it for multiple edge cases. Would you like me to help? Search function that returns -4 if the element is actually present in the list. Yes. Let me know if code will work fine or not. That's it, right? So all good, everything works perfect. And similar in case of upper bound, we can discuss it later. It's already too long, and but the thing is, I was too raw throughout the video. Means it's a raw video, and I guess this might help you to build your intuition and all. Yeah, that's it. Thank you so much. Bye.